Let's have a look at a problem featuring de Moivre's theorem and also division of complex numbers in polar form. Alright, so the first thing we note here is that we've got the numerator in polar form, but the denominator is in Cartesian form. So we need to convert the denominator to polar form. So to do that, I've just drawn up over here a number plane, a complex plane, an Argand diagram, roughly, with 1 negative root 3 indicated as W. I'm letting the what's in brackets there equal W, and that's kind of helpful for me to get my bearings. Okay, so if W equals 1 minus the square root of 3i, I am going to need to find two things, the modulus, okay, and also the argument of W. So the modulus, well, we're going to rely on Pythagoras' theorem and our equilateral triangle of exact trigonometric ratios. Because I've plotted the complex number here, I can see that theta needs to be opposite the square root of 3. Opposite the square root of 3. So, we can see that tan pi on 3 is equal to root 3 over 1. So I'm looking at that as being my argument, but I've got to notice that we are in the fourth quadrant here, so my principal argument, W, is going to be negative pi on 3. And the modulus, just using Pythagoras' theorem, is going to equal 2. Okay? Alrighty, so now I can rewrite my complex number z in the following form here. Okay. Now I need to bring up the denominator into the numerator, and that explains this line here. I simply change the index to negative 2. Bit of a trap for young players might be to forget that you are going to need to raise this 2 to the power of negative 2. And that explains how I get my 4 down here. 2 to the power of negative 2 is a quarter, so the product of my complex numbers is divided by 4. Okay, and applying the rest of de Moivre's theorem, we can see that how this comes about, this bit here. 3 times 2 pi on 5 is 6 pi on 5. And similarly, negative 2 times negative pi is negative 2 pi on 3, like so. Okay, the rest is just tidying up a bit. We know that we simply add the arguments, so that explains this line here, and tidying up, I reach the conclusion that z is equal to a quarter cis negative 2 pi on 15. Remember, I want to express my argument in the domain negative pi to pi. Thank you.